Let me know whether I am audible or not. Yes, we'll start. So these are previously asked questions from the subject power system in AP AE exams like Genco, Transco, SPDCL, EPDCL. You won't find any paper from CPDCL directly because long back CPDCL was done. So these are the questions from various exams of AP, right? Let's start without delay. Start చేసేద్దాము. Questions అన్ని సింపుల్ గా ఉంటాయండి, కాన్సెప్ట్స్ ఓరియంటెడ్ ఉంటాయి. Okay, right. The very first question is from faults. Okay, from fault analysis. Question ఏంటంటే a transmission line has a self and mutual impedances of 0.8 and 0.2. Find the positive, negative, and zero sequence impedances respectively. Find the positive, negative, and zero sequence impedances respectively. So Z1 is equal to Z2, that is equal to ZS minus ZM, ZS minus ZM, right? ZS minus ZM. Z0 is equal to ZS plus 2 times of ZM. Now, వాడు ఏమి ఇచ్చాడు? ZS ఎంత ఇచ్చాడండి? 0.8. ZM ఎంత ఇచ్చాడండి? 0.2. Do remember one thing, ZS is, for a transmission line, ZS is always greater than ZM, right? And Z0 is 2.5 times of Z1 or Z2. In fact, correct relationship ఏంటంటే 2 to 3 times of Z1 or Z2, right? ఇది కూడా గుర్తుపెట్టుకోవాలి, మీరు గుర్తుపెట్టుకోవాలి. Simple thing, that is formula is very simple. Now let us solve this. Direct answer, Z1 is equal to Z2 is equal to 0.8 minus 0.2, that is equal to 0.6. So Z0 is equal to ZS is 0.8 plus 2 times of 0.2. How much it is? 1.2 per unit, right? 1.2 per unit. Answer is 0.6, 0.6, 1.2. 0.6, 0.6 and 1.2, right? That is damn simple question. Let's move to the next question. Next question is related to cables, underground cables. Cable, grading of the cable. What does it mean by grading? Insulation grading is done, right? Grading of the cables is performed in order to achieve uniform stress. Yes, at different stages of the cable manufacturing, it is required to attain uniform stress so that cable damage will not happen. Next one is reduction in the quantity of insulation. Yes, that is also one of the important thing for us. Reduction in insulation quantity is required. Reduction in the quality of insulation, never we want to reduce the quality of insulation. So option 3 is completely, or statement 3 is completely ruled out. Statement 1 and 2 are correct. So option is A, 1 and 2 are correct. 1 and 2 are correct. Let's go to the next question. Now this is a question from voltage control. Let's read this question. We have direct formula for this. I'm not doing or I'm not going for any derivation, as it is direct formula based. Okay, the formula can be derived, but that will waste our valuable time. What is saying? A three-phase transmission line operating at Vs is equal to 400 kV has ABCD parameters. A, B, C, A and B both should be equal. Yes, for a practical transmission line, A must be always equal to D. A equal to D and AD minus BC must be equal to 1. ఒక్కొక్కసారి వాటి డేటాలో A ఇస్తాడు, C ఇస్తాడు. A will be given, C will be given. కొంతమంది వచ్చి సార్ అట్లీస్ట్ A ఈక్వల్ టు D అని తెలుసు, మరి వాట్ అబౌట్ B సార్, B కూడా ఇవ్వలేదు అంటే A ఈక్వల్ టు D తెలుసు కదా, ఈక్వల్ టు D. అలాగే మనకు ఇంకో రిలేషన్షిప్ కూడా తెలుసు, AD మైనస్ BC ఈక్వల్ టు 1. దీని నుంచి AD మైనస్ 1 by C is equal to B. ఇలా B కూడా వచ్చేస్తుంది అనమాట సింపుల్గా, రైట్? Let's read the question. A three-phase transmission line operating at Vs is equal to 400 kV as ABCD parameters. Okay, what is the value of the inductive shunt reactor required for compensating Ferranti effect? So he is saying Ferranti effect. First of all, what is the extra voltage we are getting? Extra voltage we are getting, I'll tell you. So Vs is equal to AVR plus BIR. But Ferranti effect is going to take place during no load or lightly loaded condition, means receiving end current or load current is very small. So at that time, the receiving end voltage is called as no load receiving end voltage. We are not, so VR naught is equal to Vs by A. Vs by A. How much is Vs? Vs is 400k by A. A is how much? 0.8. So this is equal to 500 kV. Means at the sending end side, we are sending 400 kV only, but due to Ferranti effect, the voltage became 500 kV. 100 kV is extra raised. Now I wanted to reduce this. See, this is nothing to do with this present question, but I'm calculating over here how to get that we are not supposed if it is asked, right? And whenever no load, the only current that is flowing in the transmission line is charging current, and there is some conductance, shunt conductance current that is very small, that eventually can be neglected even if it is long transmission also, unless it is mentioned by the examiner. అంటే ఎగ్జామినర్ కనుక ఆ వాల్యూ ఇస్తే కన్సిడర్ చేస్తాం తప్ప షంట్ కండక్టెన్స్ జీ అనేది ఆల్వేస్ నెగ్లిజిబుల్, రైట్? సో ఐఎస్ ఈజ్ ఈక్వల్ టు వాట్? సివిఆర్ ప్లస్ సివిఆర్ ప్లస్ డిఐఆర్. కానీ మనం మాట్లాడుతుంది దేని గురించి? ఫెరాంటీ ఎఫెక్ట్ గురించి. అంటే నో లోడ్ కండిషన్, IR is equal to 0. IR is equal to 0, and that receiving end voltage is VR naught. It's not VR, it is VR naught. VR naught stands for no load receiving end voltage anamata, right? Now this IS is nothing but IC, only charging current flow avutundi. IC is equal to CVR naught, right? So IC is equal to C. VR naught indaka em vachindani manaki? VS by A. So this can be written as C by A into VS. So this is how directly, if you know C, A as well as VS, you can find the sending end charging current, the sending end side charging current you can find, right? Yes, yes or not? Now this is one formula, effective formula, means CA values if you know, VS if you know, directly you will get the charging current. Now the shunt reactor, see, this is the transmission line. I'm taking a distributor parameter model. Shunt conductance, I'm neglecting it, though it is there, small value. Now here no load is there, so this voltage is more, it is high. We are connecting one shunt reactor LSH, or if LSH is connected, then it is going to have XLSH. Yes, is asking XLSH value to reduce the Ferranti effect. Its formula is directly B by 1 minus A. Parameter B by 1 minus A. What is B? B is 100. Let's take magnitude. A is 0.8. A is 0.8. I'll write here B by 1 minus A. How much it is? 100 by 1 minus 0.2. X value is what? X units are what? Ohms. X is nothing but omega L, which is ohmic value, right? 100, is it 0.8? I guess 0.8. 100 divided by 0.2 will be, how much it is? 1000 by 2. So that is equal to 500 ohms. If you connect inductive reactance of this much, Ferranti effect will be neglected. Means Ferranti effect will be removed in the power system network for this particular transmission line, 500 ohms it is. The formula, yes, there is a derivation for that which is not required for us at this point of time. Okay, don't go for derivations, directly you can remember XLSS is equal to B by 1 minus A. XLSS is equal to B by 1 minus A, right? Yeah. Now we have a question here. This question is from economics of power generation. Okay, economics of power generation. I'll explain this. First, let's read the question. It's saying the incremental fuel cost of two generating units is given by IC1 is equal to, if it is not visible, I'm reading the question carefully, try to look at it. The incremental fuel cost for two generating units is given by IC1 is equal to some value, some expression, IC2 is equal to some other expression. For economics, for economical operation, see, I'm writing here for economical operation, for economical operation, don't read that solution, that is useless for you. Operation, incremental fuel cost IC1 must be equal to IC2. The incremental fuel cost of two generators must be same. Now let's do that. 25 plus 0.2 Pg1 is equal to 32 plus 0.2 Pg2, right? This is one equation we got. Another is he's saying where the economical allocation for total load of 250 megawatts. How much is the total load? 250 megawatts means total generation. If losses are neglected, yes, as he did not, he mentioned here neglecting transmission line loss. If transmission line loss is neglected, Pg1 plus Pg2 is equal to 250 megawatts. Now, if you observe, we have two equations. This is equation 2. This is equation 1. Though I did not simplify that equation, you'll get this is having Pg1, Pg2, two variables. This is also having two variables. If you solve those two variables, you will be getting as someone solved here. That's why I'm taking those values directly. I'm not wasting our valuable time in solving these two linear equations. Pg1 is 142.5 megawatts. Yes, you can solve these two equations 1 and 2. You'll get these values. Pg2 is equal to 107.5 megawatts, right? So this way, the generation of each generator should be for economical power operation, for economical allocation of total load, for the economical allocation of total load, right? Yes, this is very easy question. Now, if transmission losses are there, way is different. Sometimes it is going to exceed the limits. Here, limits are not given. Limits are not given. What is that limit, sir? What is that limit? I will tell you. That fellow, there are two generators here. Na? There are two generators. That fellow will say, generator 1 value should not exceed 100 megawatt. 100 megawatts is the highest generation, for example. Now, Pg1 is not, see, mathematically, Pg1, Pg2, we got these values, right? But it should not be more than 100 megawatt. Now, fix Pg1 at 100 megawatt. Then, see, in 250 megawatts, Pg1 is supplying 100 megawatt. Then, obviously, Pg2 will be 150 megawatts. Okay, this way means if the limits are exceeded, this way we have to, means that exceeded limit, we have to set its a maximum mentioned value. Then other one according to the total Pg1, Pg plus Pg1 and Pg2 we have to select, right? That is economics of power generation. Now, this question looks tricky, but it is very, very easy question once you understand. Don't look at this, all this solution, which is not required for us. Leave it off, okay? Leave it here itself. The conductors of a 1.6 kilometer long 3-phase 3.3 kV overhead line are in horizontal formation with 762 mm between centers. So, 3-phase transmission line, first of all, how many conductors will be there? 3 conductors. 3-phase means 3 conductors will be there per phase. I'm not talking about buses, sir, if it is bundle conductors, more than 3 conductors. Na? So, as nothing mentioned, we are going to take single conductor system, single conductor ACSR system we are taking. So, there are 3 conductors, phase A, yes, phase B, yes, phase C. Now, you'll raise a question by saying like, sir, how do you know that these are arranged in this equilateral triangle format? How do you know that? He given only one distance. The distance between the centers is 762 mm. 762 mm, right? So, distance is equal between all 3 conductors if those conductors are arranged or kept at the vertices of an equilateral triangle, right? So, this is 762 mm. This is also 762 mm. This is also 762 mm, right? Now, what is asking, the effective diameter of the conductor is 3.5. This diameter is 3.5 mm. So, all conductors are going to have same diameter. It's okay. The equivalent spacing in mm is, equivalent spacing is nothing but geometric mean distance, GMD. Yes, I repeat, equivalent space is nothing but geometrical distance, GMD, geometric mean distance, GMD, right? Sir, don't display the answer with the question. So you don't look at it, ma, okay? So as already it is typed in this way, na? So we can't do anything. Okay, for now, you just focus on the question and solving yourself and comparing with that answer with my answer. That is the best practice as of now, right? We can't do anything, right? Yeah. Now, come here. What is the GMD of this? Let's take it as a D. So that is D. This is also D. This is also D. What is GMD of A? Geometric mean distance of A. I'll give you the way how to find GMD if you don't know. See, many of you might be knowing what is GMD. If you take this conductor is surrounded by how many other conductors? 2 more conductors. You'll get square root of Here to here D, here to here is also D. How much is that? D. The same way, what is GMD of, yes, GMD of conductor B? GMD of conductor B. B, conductor B, please, not D. Conductor B. B is having how many conductors in its surrounding? 2 more conductors. Square root of B to A is D. B to C is also D. That is equal to D. So what is GMD of C? C is having 2 more conductors in its surrounding. Square root of D into D is D. Total, how many GMDs we have? 1, 2, 3. Therefore, GMD of the system is equal to, as 3 distances are there, cube root of, yes, GMDA into GMDB into GMDC. GMDC. So that is equal to cube root of D into D into D, that is equal to D cube, that is equal to D, which is equal to 762 mm. Means, in fact, you need not to solve directly. If you know this concept of GMD, you need not to solve directly. You can tick for it. Means within no time, no calculator needed, no time needed. Just 10 seconds is enough. You remember, if the conductors are arranged in equilateral triangle format, then GMD will be equal to the distance. GMD of the system, equivalent spacing means GMD of the system is equal to distance between any two conductors, right? So that is the conclusion what we draw once we solve the given question, means once we understand the concept, right? So this is the concept of GMD, geometric mean distance. Let's go to the next question, right? Yeah, that is a simple question, very simple question. Okay, right. Now try this question, all of you. This is about GMR, geometric mean radius, but you try it. What is saying? The geometric mean radius of a conductor in terms of radius r of an individual strand for 3 equal strands as shown in figure is. Simply is asking, though the statement is very big and confusing, but still is asking only one thing, that is, what is GMR, effective GMR? Nothing but self GMD or GMR. This is a standard conductor. This is a standard conductor. So this is R. This is also 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 R. Right? R it is. Now, what is this total? This is 2R. What is this total? 2R. What is this total? 2R. Right? Let's take this one as 1 and this one as 2, this one as 3. 1, 2, 3. Now, let's see self GMD, which is nothing but GMR only. Self GMD, or let's take as that fellow given as GMR. Let's take it as GMR only. So GMR of strand not GMD. GMR of strand 1 is strand 1. If you take strand 1, its own radius is having R dash. Yeah, if you are finding self GMD or GMR, always first we have to consider the conductor its own radius. What is its own radius of a conductor? Now here R is there, but we have to consider R dash, which is equal to 0.7788 R. Sir, why it is so? That is because of internal flux linkage and all. There is a lot of story behind it. There is a big story behind it. So that's the reason why I'm not going into that depth. Why we got that R dash? Why it is exactly 0.778? So these kind of things, I'm not getting into those details as of now. Time is important for us. Now, its own conductor is R dash. 1 to 2, it is how much? 2R. Yeah, always the distance is measured from center to center. 1 to 2 is 2R. 1 to 3 is also 2R. How many distances we have? 1, 2, 3. So we will get cube root of, right? Now, cube root of 0.778 is 0.7788 R into 2 into R cube. Or that fellow given kept the options as 2R only. Let's keep it as 2R. R into, yes, R into 2R into 2R. Now, if you see, GMR of 2 also will get the same. GMR of 3 also will get the same. GMR of the system also will get the same. Why? We have three conductors which are arranged again in the form of equilateral triangle. The distance between one center to another center exactly same, 2r, 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 2r. Therefore, 1 you find, 2 you find, 3 you find, total cube root of GMR1 into GMR2 into GMR3 will remain same, right? Now, let us see the options R to R to R. So first of all, option B is eliminated. Option C is also eliminated. Option D is also eliminated. Option A is correct. Option A is correct, right? So cube root of, see, from the options, suppose if you don't know, sir, 0.7788 is e power minus 0.25, I don't know. First of all, this is e power negative only, e power negative only. Sir, how do you know that it is e power negative? If it is e power positive, e itself is more than 1, okay, and it should be definitely negative, right, as the display number is less than 1, right? So that's why option B, option D, both are eliminated. And R, 2R, 2R. So option C is also eliminated. Why? Because though it is e power negative, here R is there, again R is there, but I should get 2R here. That's why option A is correct. So why I am explaining this one is, if you don't know this 0.778, actually e power minus 1 by 4. Yes, e power minus 0.25, that is equal to 0.7788. In its particular derivation, we get that. In its particular derivation, we get that, actually, to speak. Right? Let's go to the, yeah, this is the explanation that can be given to you. Right? Now, what is this question? This question is from which concept? Try it, all of you. Yes, those who are there in the class, please try it. What is saying, ma? What is saying? The inductance and capacitance that fellow given is asking for the voltage across the circuit breaker contacts. Voltage across circuit breaker contact, that fellow given current also. Yes, is asking for the voltage across circuit breaker contacts. Right? Yes. So all these are previously asked questions. Okay. See, the formula for voltage across circuit breaker contacts is V is equal to I into under root of L by C. Right? What is that? V is equal to I into under root of L by C is the formula. Right? So the voltage induced across the circuit breaker contacts, that is equal to I into under root of L divided by C. I is 10 amperes. L is how much? 1 Henry. C is how much? 0.01. So that is equal to 10 into under root of this is 100. So 10 into 10, how much it is? 100 volts it is. 100 kV in fact. 100 kV. Why? Because I did not taken this micro into consideration. If you take this micro into consideration, you will get it as 100 kV. Option is D for Delhi. Right? Yes. Yes, correct. Who is this? Air control. Yes, that's all. V is equal to I into under root of L by C. Simplest question that is. Right? Yeah. So this is from insulators topic. Insulators topic, suspension type insulators, is asking about the string efficiency. Is asking about string efficiency. Do not refer this solution. We'll do it in a more simple way. We'll do it in more simple way. But what is saying? See, a suspension type insulator has two units with self capacitance C and a ground capacitance of 0.2 C. Now people will get confused. Sir, what is self capacitance and what is ground capacitance? Let me draw the structure. So I'm taking half of the tower. Okay, this is cross arm. Here we have an insulator disc, another insulator disc, and this is the power conductor or transmission line. So this tower is kept on the ground. This is 0 volt. Obviously, this is going to be 0 volt. Now, this total voltage applied here is V phase, because from a conductor to any 0 volt, the voltage measured is called as phase voltage. From one phase to 0 volts, the voltage measured is called as phase voltage. Now, here, this one if I draw electrically, this one if I draw its electrical equivalent, then that can be drawn as this way, right? So this is represented with the capacitance. This is also represented with the capacitance. Here we have a capacitance, right? So our this way, this is the ground. Now all this is the disk capacitance CD. This is tray capacitance. This is also disk capacitance. Now, CD is always much greater than tray capacitance. So by looking at the values, he is saying self capacitance is C. Now, self capacitance is nothing but disk capacitance. Okay, ground capacitance is nothing but tray capacitance. How much it is? How much it is? 0. Yes, 0.2 C. Yes, this is 0.2 C. 0.2 C. Now, what he's saying, he applied each unit can withstand maximum voltage of 11 kV. What is the string efficiency? He's asking about the string efficiency. You know, the formula for string efficiency is, I'm not deriving the formula. String efficiency is, see, phase voltage divided by n times of the disk which is near to the power conductor. N times of the voltage that is withstand. So which disk is near to power conductor? V2. Now tell me, how much is V phase? V phase is nothing but V1 plus V2. V2 by N is 2 times of V2, right? V phase means what? V phase means V1 plus V2. This is the phase voltage, right? This is this voltage. Let's take it as V1. Let's take this voltage as V2. So this total V1 plus V2 is V phase, right? V phase is equal to V1 plus V2. Now, it's okay, sir, but neither he given V1 nor he given V2. How to do that? Okay, but there is a relationship between V2 and V1. In fact, V2 is greater than V1. As we know that the disk near to conductor will experience more voltage, will share more voltage than the disk which is near to tower, right? V2 is greater than V1. Sir, what is the exact relationship? V2 is V1 into 1 plus K times extra. Okay, plus K, 1 plus K times it is going to be, right? Sir, what is K then? K is equal to CS by CD. What is CS? 0.2, sir. 2C, sir. What is CD? C, sir. This is gone, sir. 0.2 you got. Now, V2, I'm doing here as I find space here. V2 is equal to V1 into 1 plus 0.2. That is equal to 1.2 times of V1. V2 is how much? 1.2 times of V1. Now, if I substitute, okay, string efficiency, if I want percentage, that is equal to, yes, V phase, okay, V1 plus V2. V phase is V1 plus V2 is 1.2 times of how much we got? How much is V2? 1.2 times of V1. 1.2 times of V1 by V2. How much it is? 2 times of V2 is what? 1.2 times of V1 into 100, right? So 2.2 times of V1 by 2.4 times of V1 into 100. V1 gone. It is 2.2 divided by 2.4 into 100. Just do this calculation. Yeah, one important update, all of you, that is virtual calculator is allowed in your examination. Yes, not means you need not to carry that calculator. That calculator is given by the authorities. Yes, that is displayed on your screen. So why I am discussing about that point very clearly here is you prepare accordingly, means question will be more calculation involvement also. Questions will be more calculation involvement also. And answer is how much here? Answer is you'll get it as 91.6% around 91.6% you get. But in options it is not there. Any mistake we committed? No mistake we committed. But why? It is not. K is correct only. V2 is equal to V1 into 1 plus K. This is also correct. 1.2 V1. Okay. But he said only 2 units. Nah? He said only 2 units. Each unit. A suspension type insulator has 2 units. Only 2 units he discussed about. Why is all 3 and alls? No, it is not 3 units. It is okay. He mentioned here as 2 units, but he calculated for 3 units. Maybe 3 it is having. That's why answer is wrong. That's why our answer is wrong. But our procedure is perfectly correct. That's why our procedure is perfectly correct. Okay. Nowhere we committed mistake. Yes, it is about 3 discs. Okay, 3 discs. But here there is a typo here. I took this one as 2 discs. Yes, here it is mentioned not 2 units. That's why I took it as 2 discs. Now let us see for 3 discs. Okay, if 3 discs. Now it's okay. Only one step. So V1, V2, V3. Right? What is V1? V1, let's keep it as V1 only. V2 is equal to what? V1 into 1 plus K. What is V3? What is V3? V3 is equal to V1 into K square plus 3K plus 1. Now, what is string efficiency? Percentage string efficiency is equal to V phase. What is V phase? V phase is equal to V1 plus V2 plus V3 by 3 times of which disk is near to power conductor? V3. Which disk is near to power conductor? V3 into 100 into 100. Now, V1, let's keep it as V1 only. V2 is V1 into 1 plus K. V3 is what? V1 into K square plus 3K plus 1 by 3 times of what is V3? V1 into K square plus 3K plus 1 into 100. So V1, 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 V1 gone, right? Now the answer is very simple. 1 plus K is 0.2, 0.2 plus K square 0.2 square plus 3K 3 into 0.2 plus 1 by 3 times of 0.2 square. 3 into 0.2 is 0.6 plus 1. For this one, definitely you need a calculator. Solve it and tell me how much is the value you are getting. Yes, how much it is? 1 plus 1, 2 plus 2, 2 plus 0.2, 2.2, 0.2 square, 0.04 plus 0.6, this is 0.6 plus 1, right? Divided by 3 times of 0.04 plus 1.6. Now, 2.2, 3.2, 3.2 plus 0.8, 3.8, 3.8 plus 0.04. 3.84, I guess. Correct me if I'm wrong. This is 3 times of 1.64 into 100 into 100. Solve it using your virtual calculator. Solve it, please. Yes, it is 3 disks. That's why our answer not matched. 3.84 divided by 3 into 1.64. How much it is? Answer is 78%. Yes, I did it with my cell phone calculator. It is 78.04 percentage, right? 78%, right? Simple question. Okay, even it is 4 disk also you can calculate, but never in the examination 4 disk will be given. But in the examination, questions will be little tricky. If he wanted to give, the question will be little tricky. That fellow will give nth disk voltage, means the disk which is near to power conductor. That fellow will give nth disk voltage, that is the disk near to power conductor. Then he will be asking about what is the voltage across some other disk. This kind of some tricky questions will be given on this. But if you are good at network analysis and little bit logical thinking and common sense, you can solve this kind of questions very easily. That's not a big deal, right? Now, all of you try this question. I'll solve. I need to explain about Vibus. Okay, all of you try this question. I'm giving you 1 minute, 2 minutes of time for this question. Solve it. Okay. Once you are done, I'll solve it. I'll solve that question. This question is about Vibus matrix. Okay. Right. Solve it for a minute, please. Yes, answer please. A 5-bus test system contains 6 transmission lines and 1 transformer. How many non-zero elements are there in Y-bus? Okay, so this is very simple. Number of, see, first of all, total number of elements. Total number of elements in Y-bus is equal to what? What is Y-bus size? 5-bus, na? 5 by 5. How many? 25 elements. How many total elements are there? 25 elements. Total number of elements. Why? Because it's a 5-bus. Okay, it's a 5-bus. Therefore, the size will be 5 by 5. So bus means the number of nodes. So Y-bus size will be n by n. It is 25 elements. Now 6 transmission lines and 1 transformer. Total 7 it will be calculated. 6 transmission line, 1 transformer is equal to 7. Now if you take any matrix, Y-bus matrix, not any matrix, Y-bus matrix. First of all, 7. See, what is the size of this matrix? 5 by 5. What is the diagonal size? Diagonal. How many diagonal elements are there? 5 diagonal elements which are non-zero. Do remember, always diagonal elements in a Y-bus matrix are non-zero. I repeat, always diagonal elements in an Y-bus matrix are non-zero, right? Always it is. Now, how many non-zero off-diagonal elements will exist? Number of non-zero off-diagonal elements of diagonal elements is equal to 2 into number of transmission lines. 2 into number of transmission lines. But here, transmission lines plus transformer, 2 into 7 will be 14. So total non-zero will be how many? Total non-zero will be 14 off diagonal plus diagonal. Total 19 elements are non-zero in Y-bus. So total number, see, always diagonal elements are non-zero. Number of off-diagonal elements, number of off-diagonal non-zero elements will be 2 into number of transmission lines, but transformer also will be added into the transmission line, right? Yes, transformer also will be added into the transmission lines, right? All of you. Clear? 19 is the answer. This is very simple question, right? Let's go to the next question. This is a very good question. Okay, it is simple. If you know the concept, it is very simple. I'm giving 1 minute of time. Try to solve and give me the answer in the chat box. If you have any kind of question, you can type in the chat box. I'm here to help you with that. Okay, solve it, please. Yes. Yes, I'll tell you what is this. See, always if you take any two buses, I'm saying this one as sending end magnitude, and this is delta S. This is receiving end voltage magnitude, and the angle is delta R. And this transmission line is having reactance of Jx. Resistance of the transmission line, shunt conductance, shunt capacitance, all three are almost neglected in most of the cases. Okay, if at all they may give resistance or they may give shunt capacitance, but in approximate cases, this is the scenario, right? So between any two buses, so real power P, real power or active power will flow from high angle to low angle. High angle to the active power will flow from high angle to low angle. Do remember, to low angle means if this angle is 60 degrees, this angle is 30 degrees, real power will flow from this sending end bus to receiving end bus. So the real power flow depends from one bus to another bus. The flow of real power depends on the magnitude of the angle. The, okay, from high angle to low angle, real power will flow. And the reactive power flow Q depends upon, and it is going to flow from high magnitude of voltage to magnitude of voltage to low magnitude of voltage, low magnitude of voltage. Okay, reactive power will flow from high magnitude of voltage to low magnitude of voltage. Right now, you see active power flow. So he's saying the voltage of a generator and infinite bus are given as 0.92 at an angle of 10 degree and 1.0 at an angle of 0 respectively. So that fellow given, remove this, let's keep this is grid or infinite bus 1.0 at an angle of 0 degrees. So remove this and keep 0.92 at an angle of 10 degree. Now this is high angle 10 degree, this is low angle 0 degree. Real power will flow from high angle to low angle, means real power is flowing from generator to infinite bus or grid, right? Active power flows from generator to infinite bus, correct? Reactive power is going to flow from high voltage magnitude. See, very simply, this is the direction of P, this is the direction of Q, right? Reactive power flows from infinite bus to the generator. Yes, option is A. Very good. Option is A. Very good. That's simple concept. Yeah. Mohan Krishna and Kondalu. Good. Right? That is simple question. Let's go to the next question. So transmission lines are transposed. What is transposition? See, try to answer this one. Once you answer, then I'll go for the explanation. I'm giving you 1 minute of time for this. Yes. Answer, please. What is transposition of transmission lines? None of you answered, man. See, we have two types of configuration. One is symmetrical configuration like this, means the distances are equal between one phase to another phase. If distances are equal, obviously GMD of A equal to B equal to C. If GMDs are equal, LA is equal to LB equal to LC, right? Then reactance of A equal to reactance of B equal to reactance of C. Then voltage drop in phase A is equal to voltage drop in phase B, that is going to be voltage drop in phase C. Therefore receiving end voltages are balanced. Receiving end voltages are balanced. When if it is symmetrical configuration, if it is asymmetrical configuration, yes, this is asymmetrical or unsymmetrical configuration. This is X, this is Y, this is Z, this is A, B, C, right? Now, in this case, GMDA not equal to B not equal to C, then LA not equal to LB not equal to LC, then XA not equal to XB not equal to XC, then delta VA drop in phase A is not equal to drop in phase B is not equal to drop in phase C. Then receiving end voltages are not balanced. Not balanced. If receiving and voltages are not balanced, then system is unbalanced. That's why we are going to now when this is happening, here in this case, as currents are also balanced, net flux is equal to 0 at any instant of time. Here net flux of the power lines is not equal to 0. If to the transmission lines, if any nearby communication lines are there, the net flux is going to cut with this neighboring communication lines. Radio interference is going to happen. That radio interference is also called as telephonic interference, TV interference, right? Telephonic interference or TV interference or radio interference. These three names it is having, right? So to avoid this radio interference, we have to go for transposition. What is transposition? At regular equal intervals of distance, the positional the positions of the power conductors are exchanged mutually, A to B, B to C, C to A, so that all three conductors are going to experience same positional GMDs. If positional GMDs are equal, this is a scenario what you are going to get, no radio interference, right? Transposition is nothing to do with Ferrand effect, nothing to do with skin effect, nothing to do with proximity effect. It is interference with the neighboring communication lines. It is interference, means the transposition is done to reduce the interference with the neighboring communication lines, right? Let's go to the next question. Okay, what is this? This is our surge impedance. So surge impedance, yes, simple question. That's why I'm asking you to solve it and let me know. Yes, next question. All of you try to solve and let me know. Yes. Yes, answer please. So this is very simple question. He's asking about surge impedance. He's asking about surge impedance. Surge impedance ZC or characteristic impedance or natural impedance all are same, under root of L by C, and it is independent of length of the transmission line. It is independent of length of the transmission line, right? Its value depends upon inductance and capacitance values, and there are many other formulas. This is approximate formula. What is the exact formula? Zc is equal to Zs is equal to under root of R plus j omega L by G plus j omega C ohms. If this way it is given, or Zc is equal to Zs is equal to under root of B, parameter B of the transmission line, by parameter C, or another formula is under root of ZOC into ZSC. So if any of this data is given, you can utilize that data. You can utilize that data for finding this, right? Under root of L, what he said, the surge impedance of 60-mile long underground cable is 50 ohms. For a 30-mile length, it is independent of length, as I told you. Yes, sir, it is 50 ohms only. I didn't read the complete question, just I keep on giving you these formulas, right? So it is independent of length. Okay, L per meter, then you have to take C per meter. If it is per kilometer, it is per kilometer. So like that, it is either, see, it is independent of transmission line length. ZC is independent on length of the transmission line. ZC is independent on the length of the transmission line, right? Yes, that's a quite simple question. Okay, but the formulas I given are very important. The formulas I given are very important. Okay, right. Next question. Okay, this is from underground cables. This is from underground cables. Read the question, try it. Once you are done, I'll see, at least from one person I'm expecting the answer for the question. At least from one person I'm expecting answer for this question. Okay, so let me read the question. Question is quite simple. A single core cable is designed to work for a single phase system with peak voltage of 220 kV. That's fine. You're saying peak voltage is 220 kV. The maximum permissible stress in the dielectric is not to exceed 20 kV per mm. He is saying the maximum electric field intensity, stress means dielectric field intensity, it should not exceed 20 kV per mm for economical size. The overall core diameter of the cable is asking overall core diameter of the cable. So, see, E is equal to, electric field intensity is equal to V by R into ln of R by R, kV per centimeter. That fellow given this E max, and he is asking for economical size. Yes, he is asking for what? Economical size. For what is the relationship for economical size? Capital R by small r must be equal to E. Okay, capital R by small r must be equal to E. So that fellow given this one as 20 kV per mm. This is in per centimeters. This is in centimeters, right? Now convert into mm. 20 kV per mm is equal to V by, yes, V is how much? 220. Okay, this is 220 into 10 cube, or this side is kV, na? Let's write this also kV by R. Okay, radius, right? R into ln of capital R by small r is ln of E. That is equal to how much? Ln of E is 1. Yes, ln of E is 1, right? So from this one you will get small r. Now what is asking? Yes, from this one you will get the value of small r. You can get capital R also. Why? Because capital R by small r must be equal to E. That is small r is equal to capital R by E. This way also you can do, right? Just this calculation part I'm leaving it to you. What will the answer? Answer is D is saying, just you can verify. Just you can verify the same process it is. So he's asking, see, smaller you got it as 11 mm. Then diameter you are going to get 22 mm, right? Answer is very simple, right? Calculation part just I left to you, calculation part, all right? So that is quite simple question. Okay, everything I given here, just do the calculation, not more than, right? Yeah. Stringing chart is used for, yes, stringing chart is used for finding the sag. This is theoretical question. Stringing chart is used for the calculation of sag. Okay, do remember that is silly question. You have to spend more time there. Here, this is also very simple question. Okay, try to solve. Get previous year questions, 2 marks. Questions this time they will give not exactly. Okay, not exactly until unless they feel like testing your knowledge. Okay, and one more thing, let me remind you one thing. They may give previous year gate questions with some change in numericals, because gate questions only IITs only can create. See, here something very important I want to discuss with you, that is, gate questions only IITs can design. Okay, why? Because see, I'm not degrading anyone, but that depth of questions only gate can design, only IITs can design. What the state government can do, state government paper giving people can do, is they may take previous gate year gate questions. Option one is they may give exact questions as it is, or if they feel like should not give exact previous questions, not giving exactly previous year questions, what they will do is they will change some numericals and they will give previous year questions. They will change some numericals and they will give previous year questions. But designing the questions at the gate level is not that easy. Yeah, virtual calculus, that's what I'm speaking, Mr. Sridhar. Mr. Sridhar, that's what I'm speaking. The point here is gate level questions only IITs can give. State government professors or some universities, they can give some questions of gate level, some 3, 4, 10 questions, but not that tricky. Okay, what these people can do is they may give exactly previous gate questions without changing even numericals, or they may give questions by changing numericals, right? But creating questions at the gate level by IITs only most of the times, right? So 2019 mostly power electronics, power systems, electrical machines are previous year questions only gate IES, same copy. That's what I'm saying, Sridhar. That's what I'm saying. Uh, okay, IIT Tirupati is preparing questions. Yes, can be expected then. I was not having information that IIT Tirupati is preparing questions. If IIT Tirupati is preparing questions, then definitely question level will be near to gate level. Near to gate level. Okay, I repeat, if IIT Tirupati is preparing paper, the questions will be near to gate level. That's why be wise in solving. Try to solve all previous year gate questions. Try to solve all previous year gate questions by learning the concepts. Okay, by learning the concepts. In most of the times, also, what state governments did is they given previous year gate questions only with 1 mark questions, engineering services paper questions, without changing even single numerical. Previous year questions as easily they dumped. I think this time it's not going to happen, as you people told me that IIT Tirupati is giving the paper. If IIT Tirupati is giving the paper will be good paper. Okay, they are going to take the people who really learn the concepts, right? Who really learn the concepts. That's better for you, in fact. Okay, only cream will be selected, right? That's always a great thing to have, right? Next question is what is saying the inertia constant of two groups of machines, okay, which are swinging together. Yeah, we have two options like swinging together, not swinging together. If machines are swinging together, M equivalent is equal to, that is very simple, like equivalent resistance M2 and so on Mn. If this is for swinging together. If machines are swinging together, that swinging together is also called as or coherence. Both machines are in coherence or in unison. Yes, all three carry the same meaning. Means what? Delta 1, load angle delta 1 is equal to delta 2 is equal to delta 3 is equal, and so on, delta n. That is the meaning of swinging together or in coherence or in unison. Not swinging together, that is simply like parallel combination of resistances. 1 by M equivalent is equal to 1 by M1 plus 1 by M2 and so on, 1 by Mn. Yes, this is for what? Not swinging together. Not swinging together. Right? That's the meaning. Now, as these two are swinging together, option is C, M1 plus M2. That's not a question at all. Okay. Yeah, preparing gate IES questions will help. Definitely will help. But if you prepare with the concepts, okay, not just mugging the answers or mugging the process. If you really understand those questions and concepts and you're able to solve, definitely it will help. I always recommend students to solve all previous year gate questions and engineering service examination questions. That really 80% of the questions will be from that only. At least I'm not saying exactly same. I'm not saying exactly same, but models or concepts will be repeated. And sometimes gate also will repeat questions, models, not questions, models, because it's been years, 25, 26 years of gate paper, from where they also prepare new questions, right? That's the reason why if you take paper, any gate paper, either paper will be lengthy, involves more calculations, or uh, sometimes what happens is, suppose if you take some gate papers, most of the previous year models are repeated, not exactly questions, not exactly questions. That's why, see, the best strategy is, and no one can prepare gate question level questions. Therefore, it is always means, what my point here is very simply, gate is having highest standard, and somewhat up to some extent engineering services paper also. So if you prepare those, you are having good depth of concepts. You are having good depth of concepts, right? That really helps. That really helps. Okay, right? Best book for computer knowledge and proficiency, sir. Sridhar, I am electrical faculty man. I have least idea about that. Take my number. I'm giving my contact number here. You just contact me. I will make you to connect with non-technical faculty. They will guide you what the best book for this computer knowledge and proficiency, right? 3 years exam, virtual calculator means paper will be same, somewhat near to get. Yes, until and unless they want to fool us. అంటే నా మాట ఏంటంటే, అంటే నా పాయింట్ ఏంటంటే, ఇన్ని పెట్టారు కదా, అంటే ఎగ్జామ్ 3 అవర్స్ మార్చారు, ఫస్ట్ థింగ్. సెకండ్ థింగ్ ఇస్ వర్చువల్ క్యాలిక్యులేటర్ ఇచ్చారు, అంటే పేపర్ మంచిగా గేట్ లెవెల్ వరకు ఇవ్వాలి. అలా ఇవ్వకుండా అంతకు ముందులాగే ప్రీవియస్ ఇయర్ క్వశ్చన్స్ తప్పులతో సహా అలాగే ప్రీవియస్ ఇయర్ ఎగ్జామ్ నుంచి ఎత్తి పడేశారు, అనవసరమైన థియరీ క్వశ్చన్స్ ఇచ్చారు అంటే, దే ఫూల్డ్ us. They're going to fool us, in fact, right? కాబట్టి ప్రిపేర్ ఫర్ ద బెస్ట్. వర్స్ట్ కేస్ పేపర్ టఫ్గా ఉంటుంది, క్వశ్చన్స్ డిఫికల్ట్ క్వశ్చన్స్ వస్తాయి అని ప్రిపేర్ అవ్వండి. ఓకే, ఎందుకంటే 90% ఆఫ్ ద ఛాన్సెస్ దానికే ఉన్నాయి. కానీ సర్ప్రైజింగ్లీ మోస్ట్ ఆఫ్ ద టైమ్స్ దే గివెన్ వరస్ట్ పేపర్స్, సింపుల్ క్వశ్చన్స్, సమ్ కార్నర్ థియరీ క్వశ్చన్స్, ప్రీవియస్ ఐఎస్ క్వశ్చన్స్ యాజ్ ఇట్ ఈస్ డంపింగ్. సో దట్ కైండ్ ఆఫ్ నాన్సెన్స్ దే డిడ్. But still, being engineering graduates, we have to take our stand and we have to prepare at that level only. Why? Because paper is of 3 hours and virtual calculator is allowed, right? And here, why I'm not saying that equal to gate level. Gate paper is 65 questions only, but here is 100 questions, right? 30 plus 70. That's why not exactly gate level, little less than gate level will be given. Not gate 1 mark question, 2 marks question, in between depth will be given. Okay. Yeah, so this is a straightforward question, previous year question. Okay, the per unit synchronous reactance of a machine is 1.6. It's a short circuit ratio. Short circuit ratio is 1 by reactance. That's all. Okay, that is waste of time question. I'm not solving it, right? Corona loss in transmission lines can be reduced by using bundle conductors. By using bundle conductors, corona loss is because of electric field intensity. That electric field intensity can be reduced by increasing the effective diameter, effective radius, in fact, not diameter, effective radius, right? Using small diameter conductors, no. Using bundle conductors, yes. Using bundle conductors. Option B is straightforward. Option B is straightforward. See, the purpose why we are going for bundle conductors is to reduce corona. The purpose why we are going for bundle conductors is to reduce corona, but there are some other advantages with the use of bundle conductors. I repeat, with the use of bundle conductors, power transmission capacity will increase. For a transmission line, power transmission capacity will increase. Or if you sacrifice the power transmission capacity, I can say stability of the power system is going to increase, right? And I can say the reactive power drawn by the transmission line decreases. The reactive power supplied by the transmission line is going to increase. Voltage drop in the transmission line is going to decrease. Voltage regulation decreases, right? A lot of advantages it is having, right? Yeah, Sridhar. Yes, sir. At least 40 to 50 questions will be gate level, remaining easy. Maybe. Yes, you are right. But state governments are always give surprise, right? See, AP EPDCL 2014 paper, if you see AP EPDCL 2014 paper, if you see, paper is near to gate level. Yes, and in fact good conceptual questions are given. Very good conceptual questions are given in AP EPDCL 2014. See the paper once. Okay, very good questions were given. Okay, that kind of paper can be expected. That kind of paper can be expected. Okay, right? So we started a dedicated module. YourPedia started a dedicated module. Only question practice. Okay, learn concepts through questions is our module. Learn concept through questions is our module. Our module is at a very low price, that is 3,000 rupees, 2,999, not even 3,000. So thousands of questions we will be solving. Thousands of questions we will be solving in the entire course. Okay, it will we will be giving test series for this also, test series and formula sheets, not theory classes, no theory classes. Okay, many of the students are attending daily live classes from 3 to 4:30 p.m. and 5 to 6:30 p.m. Right? So if you any one of you interested, yes, you can join our module. You can contact us. Right? As I mentioned, my number. You can message me on this number. You can join our module. Right? All the best. Thank you.